All right, I guess I'll try doing music again. Okay. Wait. Okay, that's what I'm gonna try to go with. Then, countdown should be announcing soon. Nope, looks like it's broken. Um, I'll just copy my Twitch from somewhere. Great. And I'll hang around here for a while. So I don't start when no one's there. Although a few people have asked to just to download it, so I'll probably go through the lesson, even if no one's there to see it. Also, as a disclaimer, a lot of the geometry in this lesson is pretty annoying. And so I guess I'm sort of liable to mess it up as a heads up. Also, I should probably move over some of the boilerplate code. Like the axes construction. That's not particularly useful. I guess I'll go for 5 minutes after. Until then, I could put some work in on a new tweet I've been thinking of. Let me try doing some of that. So require importing Manim. I'll just call this lens. Even though I won't be working on this for long, might as well get started. Or do a little bit with it. Let's just make sure that's working. It is, okay. I need to come up with something to be a lens. So I think I guess I could start with just something like a rectangle. But it had to be composed of 4 lines instead of the rectangle class. So it'll be rectangle class. So it'll be something like to come up with something for its height, maybe like 3. and its width maybe 1. And then from there, I'll have to add lines to the sides. And this could just go from up times lens height over 2. Plus left times lens width over 2. And going down. So down. Oh, what did I do? There we go. Do this, and I'll just add that. Okay, then I'll have to do that for the other side. And I'm still doing a lesson, by the way. I'm just waiting for, I guess, 1 more minute. So I'll do this for the right. Okay, cool. And then the top and bottom. Up plus right. This should have to be up plus. That should be left, and that should be right. I'll add the bottom in. Okay, and the sides of a lens are supposed to be curved if you look at a science diagram. But I can work on doing that a bit later. How much time I got? Okay, so it's 6:05 now, so I'll stop doing this. I'll go to the lesson. Okay, so if you haven't seen it already, the notes for this lesson are in the Discord already. That has the source code I'm going to be going through. I'm also going to pull it up on the side in case I get lost or something. I'll just have it there. That's one reason to have it. Another reason is that there's some information, like creating the configuration for the number line we're going to be using, that just isn't very instructive since we've already gone over how graphing and how plotting works. So I'm just going to bring that over. So I'm going to do this boilerplate, same thing, from Manim import star. Well, star. And I'll do a class coin flip. Yeah. And so what this is going to do eventually is I'm going to be plotting the cumulative probability that a coin comes up heads. And the way that I'm going to do that is by flipping a coin, or virtually flipping a coin, several times, and then updating a graph with the running cumulative probability of picking a heads. So in order to do that, first of all, I'm going to need a number line. So I'm just going to bring that over the config from the notes, because that isn't very instructive to just write out all this config. The source code is on the Discord if you want to follow it. But that's what I'm just going to bring it over from there. Then I'm going to have this number plane. And, you know, this is a configuration. It's going to have this buffer distance. This is the color. It's going 0 to 10, which is actually going to be significant. And the y values go from 0 to 1, because the probability is going to be from 0 to 1. So I'm just going to add this in. And wait. And great, we've got a graph from 0 to 1. So then it's going to come the drawing this graph. So the way I can do that is I'm going to have some list of coin flips. So I can just have coin flips. And instead of like H or T, I'm just going to fill this with zeros and ones, something like this. Fill this with zeros and ones, something like this. And 1 is going to be heads, 0 will be tails. And so firstly, I'm going to have to draw the graph that I want to appear here. So what I'm going to want to draw is the cumulative probability of picking a 1 or heads. So I'm going to do this with an updater, but first I'm going to draw it manually. So this will just be a for loop. I'm going to have a result. Graph, I'll call it. Yeah, graph will be a V group. And then I'm going to go for flip in coin flips. I'm going to have a dot. And I'm going to want to color it. Dot set color. And that color is going to be different based on whether it's heads or tails. So say if coin flips 0 is a 1, I'll make that red. And just else, I'll make that blue. And for now, I'm just going to put them somewhere random on the graph. So let me just do dot dot move to, and I'll do chords to point, plane dot chords to point. And how about I 0.5. All right, then I'm going to have to add that dot to the graph. Graph dot add dot. And then I'll just add this graph. Okay, and I don't have I here. I'm going to have to do enumerate here. Oh, and this should be flips at I. Coin flips at I. Okay, let's see if those are placed. Great, that's perfect. That's perfect what I'm looking for right now. So I'm going to want to update this graph over time. Well, first of all, I'm going to want to place them where the cumulative probability is. And then I'm going to update these over time. So the way I'm going to do that is I'm going to use always redraw so that this graph gets redrawn on every frame. And I'm going to use an updater to increase the time on every frame. So to start with, let me compute the running probability. And to do this, I'm going to, this is going to be the number of heads divided by the total number. Probability equals. And this is actually going to be different for each dot. So how would I want to do this? I'll do it this way for now. I'll just say coin flips. I'm going to take a slice up to I plus 1, I think I'll have to do. And I want to take that length over the length of the entire thing. Okay, then I can move this to I and then probability. And this, I'll also have to take the slice. Okay, so this is going to take everything up to and not including I plus 1. So this is what I'm going to want to do. I'm going to take out this variable. Oh, this dot count of 1. I also want to take the count of 1s there. All right, so I'm going to see if this updates that I expect it to. What's this? That might be a false flag. Let me see. Nope, int has no len. If coin flips at I equals 1. Coin flips at I equals 1. What happened? one of these is an integer, I guess. Coin flips of I plus 1 dot count. Yeah, that's true. This shouldn't be the line. This is just the count. And it should actually be that count divided by the total. Okay. You'll see it. You'll see the mistakes and everything here. All right, so that looks good. Now to update this over time, I'm going to want to do this in a loop with something called always redraw. So let me make this a function. I'll call this draw graph. And it'll do this. It's going to return the graph at the end. And then I want the graph that I'm always adding, to be an always redraw of draw graph. Okay, and this should be redrawn on every flip. Okay. So let me just do this to make sure there's no crash. Great. And I'll print in here to make sure this is being called. So then that was called twice. Oh, I guess because I'm waiting, it isn't being updated. Oh, I see what I have to do. This should be a lambda on, I think, nothing. And this is what will return, is draw graph. It was still only called twice. Let me see if I was doing this wrong somehow. Nope, that was done. A lambda, which calls this. It might be because it's never updating, and that's why it's never being called. Okay, next thing to do, I'm going to pass this. This won't just be constant. Instead, I'm going to pass a time, which will be determined by a time tracker. So this is going to start at 0. This will take in a time. And this, what I'm going to return, is going to be draw graph at time tracker.getValue. So I'm still going to add the graph, and then I'm going to animate the updating of the time tracker. I'll just set this to 10. And I'll just print out the time. This is here. Great. And so now it's actually being updated on each frame, and this is slowly moving towards 10. Okay, now to update that graph. So this is being called on every frame. Say that I want one coin flip to be added on every second. That means I'll have this coin flips array. I'm going to say if the length of the coin flips is less than time, then I'm going to want to add a coin flip. So I can just do coinflips.append random.choice. It's going to choice between 0 and 1. So like this. And I'll just do that. And, oh, I have to input random. So do that. Does everything look right here? Okay, I think that looks good. And of course I'm gonna start this empty. Hopefully I won't get any divide by 0 errors. Great, so this is building that graph up as time goes forward. Okay, now we don't want this to just go off the end. I want this to instead to for the points to shrink in so that they fit within the graph. So in order to do that, I'm gonna have to shrink these coordinates down so that they all fit. First things first though. Let me update this so it's actually running at 1 second. So I can do runtime equals 10 and rate func equals linear. So now it should be one dot per second. Okay. And then I'll actually want it to be faster than 1 dot per second. So let me set it to instead of this, it'll be if it's less than time times dots per second. I'll set dots per second to be something like 5. Okay, so this should go a lot faster now. And it is faster. I think I want it to be maybe a bit faster still. Oh, I think I ran the wrong thing. No, that was fine. Did I call this the wrong thing? Why did it say lens is not a scene? This should be coin flip. I think I messed up my task. Give me a second. This should be coin flip. There we go. Although it does say that's not in the script either. Class live coin flip. There. Okay, I don't know what was going on there. Anyway, we've got this now. So we're going to want to shrink this with time. And the way to do that is currently these dots are going to be positioned in quote unquote time space. So the time, or time times dot per second, will always be greater than or equal to the number of coin flips. So what I want to do is divide the length of, or divide the length from the leftmost point of the graph to the dot by the amount of time that's passed so far. And it'll actually be time times dots per second since that's the number of dots. So I'm gonna write out this stretch ratio. And I want the rightmost point to be at 10. I'm going to divide by the current rightmost point of the time, which is time times dots per second. I have to use parentheses here. And this is going to shrink that distance of time times dots per second into the space of 10. Okay, and to do that, I'm going to have to go through all of these dots and then shrink them. So for dot in, I want to do this after iterating through the coin flips. So I'll do this here. For dot in graph, I'm going to get its x coordinate. So current chords, that's going to be plane dot points to chord of the dot's center. So this is the points, or this is the coordinates of each dot, and that's going to be stretching far to the right. Then I'm going to shrink down the x coordinate. So I'm going to say dot move to plane dot chords to point. And then I'm going to take, I'm going to have it in a numpy array. And the x value of that coordinate is going to be shrunk, or that's what I'm going to want to do. So I'm going to say current chords at 0 divided by, or multiplied by, the stretch ratio. The y coordinate can stay the same. And the z coordinate will be 0. Okay. And if we're lucky, will I get an error? Attribute has no chords to point, or what was it? Points to chord. Lane dot points to chord, what was it called? Now that's definitely a plane. Number plane has no attribute points to chord. Is it point to chords? Okay, that actually worked, but I get a different thing. Let's see what the problem was with this. Chords to point of this. I actually ran into something similar to this before. And I think that I was indexing this wrong. So I'm going to do is just make sure all these data types are the right thing. So this will be the current chords. I'm going to say current x equals current chords at 0. It should be current x. I'm just going to break here. And make sure this is what I expect it to be. So the current x, that's 0, that's right. The setup is awesome, thanks a ton. What are you using to have editable code sections in the error message like that? Oh, it's not editable. It's only, it just looks like that. And actually, I'm not sure why it does this. It just started doing it one day. But I could look more into it to see exactly why that happens. Okay, and so from looking at this, I now think I see what the problem was. This is chords to point, but I'm passing in a point. So let me put in just the coordinates. So now it's these coordinates. Let me move the stretch ratio out. Okay, I think that's everything. I think it's a poetry thing. I started using poetry and that showed up too. Okay, that might be it. I don't know what this expected expression error is. Oh, it's unmatched parentheses somewhere. That must have been it. Okay, let's see if this shrinks the graph. And perfect. So now, as the points are being created, they're being shrunk into the dimensions of the graph. Cool. So to just make this stand out a little bit more, I'm going to plot a line at y equals 0.5. And I'm going to do that manually because the axis config is just too complicated. And I tried to get it to do it for a little while, like with the numbers to show here. I'm pretty sure this won't work. Yeah, it just appears with a 0 there. So I'm just going to do that manually. I'll say half line. I'm just going to go from plane dot chords to point. And this will be 0 and half. It'll be where it starts. It's going to go to plane dot chords to point of 10 1 half. Okay.